Welcome to Domain 3, Section 3.1, Security Controls. In this session, we will survey the controls that protect AI, the major control categories, using AI within security tools, control frameworks, access controls, zero trust, the acceptable use policy, audits and traceability, supply chain controls, shadow AI, and AI incident management. Why does this matter beyond the exam? This is the practical toolkit for actually defending an AI system. Understanding these controls lets you judge whether an AI deployment is genuinely protected, choose the right safeguards for the way your organization uses AI, and close the gaps that traditional security tools leave open. Let's start with a key idea. AI security is more complex than traditional controls like firewalls and antivirus, because the right controls depend on how AI is used, whether to solve internal problems, speed up product development, or build models to sell. So, an organization may need to augment existing controls or add entirely new ones, guided by its risk assessment. The controls span several broad categories. There are technical, security, and privacy controls, covering data quality, access controls, configuration management, testing, encryption, and AI incident management. There are operational and lifecycle controls, like data flow documentation, decision-making documentation, change management, version control, and continuous monitoring. There are development lifecycle controls across the ideation, design, and deployment phases. And there are ethical and human value controls, including ethical impact assessments, consent management, bias management, transparency, and human oversight. The unifying point is that AI change management ties these together, making sure every change to the architecture is considered against its security impact. Let's look at the highlights, starting with using AI inside your security tools. AI helps defenses evolve as fast as threats, automating repetitive monitoring and log analysis so humans can focus on complex problems. Established tools for collecting security events, for automating response, and for extended detection now embed AI, and behavior analytics tools use it to spot anomalous user activity. Next, control frameworks. Because AI demands re-examining old controls and adding new ones, several published frameworks can guide you, from the NIST risk framework and a cloud security control matrix, to the adversarial threat knowledge base and a top 10 list for language model security. Access controls deserve special attention because AI blurs the usual boundaries. Picture a supervisor who normally cannot see staff records, but who is granted access to a workforce planning model that happens to contain those records. Suddenly, they can reach restricted data through the model. So an AI access policy must specify the authorization, duration, and type of data accessible, using role-based access, multi-factor authentication, validation for mixed data models, and a review of access after every release, so reviewers lose access once they no longer need it. Zero trust extends naturally to AI. Never assume, always verify. The traditional pieces apply, including identity and access management, network segmentation, encryption, data loss prevention, behavior analytics, and continuous monitoring. But zero trust in AI goes further. A model's decisions are not automatically assumed correct. To truly trust a system, weigh three things: its ability to perform the task reliably, its integrity in processing data without manipulation, and its benevolence in adhering to do no harm principles. And because internet access greatly increases risk, especially for language model applications, controls range from denying internet access outright to filtering restricted sites and validating the data the model can reach. Several more controls round out the picture. An AI acceptable use policy states the big picture framework for responsible use, communicating what is required and prohibited. Audits and traceability let you track how data moves and how decisions are made, countering the black box problem, supported by metadata logging and model cards. And three more are essential. Supply chain controls. Since most organizations rely on vendors, requiring expanded due diligence into a vendor's AI integration, data practices, and even their own sub-vendors. Shadow AI controls, to find and either remove or absorb unapproved AI tools before proprietary data leaks into public models. And AI incident management, adding AI-specific definitions and contingencies to the existing incident program to handle breaches, bias, safety issues, and ethical violations. Let's bring it all together. AI security controls span technical, operational, development, and ethical categories, all bound together by change management. Highlights include embedding AI in security tools, adopting published control frameworks, tightening access controls for mixed data models, extending zero trust to distrust the model's own decisions, enforcing an acceptable use policy, ensuring audits and traceability, securing the supply chain, eliminating shadow AI, and adding AI to incident management. You now have the full control toolkit for defending AI. Every important topic and idea from this session is covered in the multiple choice questions on RooCloud.com. Before you move on to the next session, work through the chapter-wise questions there, because this control landscape is broad and recall is what makes it usable. Practice first, and then move forward with confidence. Thank you for watching, and I will see you in the next episode.